And we'll be doing this much later. And it looks like this.
Okay, all right.
And those 2 points would never ever have a line connecting them.
Because you did not indicate it was continuous.
Because I did not indicate or did not tell you that it was continuous, there's no guarantee that I can connect these 2 points with a line. Because this graph goes off forever downwards and this one goes forever upwards. And they never ever touch, which is kind of cool. That was a trick question on a calculus exam. I said it did. I was an idiot. I didn't read all the conditions.
But you knew the answer.
I knew it. I knew the answer if I thought about it, but I didn't think about it. And that's the danger with math. If you just assume things are true, you're going to get kicked a few times. Okay, so that's intermediate value theorem. Yeah. Next topic.
Topic?
3. Yeah, we have time.
That's not what I'm saying.
Yeah, we do. 3. 3. 3. 3. 3. 3. 3. 3.
What?
Yeah, I'm not sure you want to know. I'm not even sure what you came in.
Polynomial division.
3,
3, 3. 3, 3. Polynomial division. For instance.
I'll let you check my notes out. Let's see. Whoa.
Remember P4? I taught you how to add polynomials, subtract polynomials, multiply polynomials, but I never did division. Well, here it is. Division.
I hate division.
Now, there's something that you will. This division is not really that. This one is. This one is.
So is
Kinda
it
like-
an example or is it?
But division's really important. Why is division important? Well,
Things up.
if you take 7 and you divide it into 35, how many times does 7 go into 35? 5 times, and then you multiply it down and you get a remainder of 0, right?
Yeah.
Why is that important?
So you
The
know
long division.
to break
I know.
35 up.
What, say it again?
To break 35 up.
To break 35 up. That means I can take 35 and write it as
7 5 times.
7 times 5. With no remainder. Because if there was a remainder, it would mess up this a little bit. So if I can find a division like this that has a remainder of 0, I'm taking the original polynomial and factoring it, breaking it into smaller pieces.
Gotcha.
Because polynomials are not just squares, which we can work with easily with the quadratic formula. They become cubes and fourths, and the highest we're going to go is fifth. And we have to break them up into factors. So long division is going to be part of that. All right. So how do I long divide? Well, it's actually kind of simple. You concentrate on the first 2 terms. The divisor, remember that's called the divisor. What's this one called? Inside the... Like, the 7 here is called the divisor. 35 is called the...
Oh,
Come on, you learned this in 4th grade, guys. What is it?
I don't know.
Begins with the D.
it's a
Divide.
Dividend.
Dividend.
Dividend. The 5 is called quotient, and the 0, of course, is
A 0.
the remainder.
Remainder.
It's called the remainder. So we're going to take the divisor and we're going to work with the dividend. But we only work with the first 2 terms. We ignore everything else for a second. And you say to yourself, well, what times 2x is going to give me 16x squared?
8x.
8x. So you put 8x on the top. But when you multiply it, you got to be careful. It's got to distribute over both of them. Oh, you already know how to do this? I don't have to teach you.
Yeah.
No, keep going, because I have a feeling you're going to twist it somewhere.
Never, never, never.
No.
So this becomes 16x squared. And then 8x times -3 is -24x. Now, just like over here, you had to tag in that minus sign, right? So you have to take this whole thing I just wrote down and subtract it. Now, when you subtract it, all that does is change
Your sign.
your signs. So this is not -24 anymore. It's now
Positive.
positive 24. These two should cancel out. This is 24x plus 10x, which is 34x. And then bring down 12.
And you start all over
And
again.
you start all over again. What times 2x is 34x?
17.
17. Positive 17. Distribute it down. The first one should be exactly the same. The second one is 52. 51.
What, 17 times
17
3?
times 3.
51.
51. And it's negative, so this would be -51. But you have to take that whole thing and
Draw the line,
subtract
change the
it.
sign.
And if you want, you can change all the signs. I just make it positive 51 plus 12, 63. So my final answer here is my quotient
With the remainder of 60.
plus, and since this is positive, I'm going to put plus 63 over
R.
2x
Oh.
minus 3.
2x minus 3.
Oh, when I was in like,
I know, you're not going to write R.
oh, when I was like R and 63 plus.
When you do 70, 7 goes into 30. How many times does 7 go into 30?
4.
4. 4 times 7 is?
28.
28. You subtract them, you get a remainder of 2. The answer here is 4 and
Plus.
Yeah, 4 sevens.
Plus,
Or 2 sevens.
2 sevens. So it's 4 and 2 sevens.
no.
Or 4 plus 2 sevens. So remainders are always fractions. Cool.
Why
I don't
we
do
just
the
R.
R. The R thing works if you want to learn modular math.
It's the easy way.
Modular math is awesome.
That's
Okay.
real hard stuff on these.
Now, we can write this out a little bit. This is 16x squared plus 10x plus 12 divided by 2x minus 3 is equal to this mess. What's really cool is if you multiply both sides by 2x minus 3, you get 8x plus 17 times 2x minus 3 plus 63, the remainder. That form is called, it's either Euclidean Division or, it's one of those famous mathematicians' division.
Okay.
It's an algorithm that they used to use before they did the weird stuff here. And it actually worked really well for a lot of different things. So, what I'm going to do is rewrite this as p of x divided by, I'll leave it as 2x minus 3, is equal to, this thing we're going to call q of x. Why q? Because the top answer is called the quotient. Plus, and then this piece right here, we're going to call it r of x. So this is kind of the general setup of all of these long divisions. You're going to take a polynomial, you're going to divide it by something. Usually we call this x minus c, but that'll come back. And it's going to equal some quotient polynomial plus some kind of rational function. This is not a polynomial. R of x is generally either a constant or a rational function. So q of x and p of x are the only polynomial functions here. You might want to write that. P of x and q of x, polys, functions. But r of x can be anything.
Okay, so what do you want the answer to look like? What's the
Exactly like this setup.
Huh?
Well, you don't have to write the left-hand side, but the right-hand side. You have to write the quotient plus the remainder.
Which is the 8x plus 17.
Which is this then?
When we came up with on top, the quotient
Yeah.
at the top.
I need you to get used to the symbols though, because we're going to be doing proofs.
Oh,
soon.
hey. So that's the curveball.
That's the curveball, yeah.
What's the curveball?
Proofs.
Proof. We have to know how to divide so we
How about? No, you don't have to divide to get proofs. You just have to work with the ideas to get proofs. Not that one. Not that one. Ooh, this one. How about this one?
Make it real
Did you
good.
say it was boring?
Boring.
Make it real good.
X to the fourth minus 2x squared minus 5 divided by, x minus 1. It's still somewhat boring.
So we can long divide that out, or
Ow.
We're going to long divide it. Now, don't write this down. I'm going to do this really quickly. So let me just write this and then we're going to erase it or start over again. This is x minus 1 as the divisor into the dividend, x to the fourth minus 2x squared minus 5. So don't write this because I'm going to make a mistake. I'm
You
gonna make a mistake.
won't make a mistake.
I am going to make a mistake. Well, not a mistake, but a difficulty. What times x gives you x to the fourth?
X cubed.
X cubed. If you put x cubed up here and you distribute it out, you're going to get x to the fourth minus x cubed.
Yeah.
And then we're going to subtract it away.
But that doesn't gel.
That doesn't gel. Why?
We need a space. You're missing x cubed.
Those aren't like terms.
Yeah.
So what you need to do for long division and anything else I do with this stuff,
Oh, you're going to be old.
you have to go x minus 1 goes into Polynomials are like our number system.
Right.
When you write 1092, you read it as 1092. What's the 0 for? It's a placeholder. And if you look at our number system, this is the 1s, this is the 10s, this place would be the 10 squares, this place would be the 10 cubes.
What?
Yeah.
What's he gonna do that?
What is our number system? You better know our number system.
Yeah, I know.
Yeah, but if I put it on another number here,
You got your tens.
this would be the 10 to the
I got you.
fourth. This is like a polynomial if you think about it. This is x squared, x cubed, x to the fourth. We need to show in long division all the place values. So what place values are missing in my polynomial?
X to the third.
So I'm going to put in 0x to the third because it's really not there. And 0 times x to the third is nothing, and nothing plus nothing is whatever you added that up to begin with. Plus, nope, I'm sorry,
Oh,
minus
Minus 2.
2x squared.
2x squared plus
Minus
Zero X.
Oh, minus.
0x.
Yeah.
0x.
Yeah, I didn't see that.
I don't have an x there, so I need to put it in. And then finally,
Minus 5.
minus 5.
That's terrible.
Woohoo!
So you
It's a
always-
place value system. You have to consider all the places. So now this number is 1, 0, negative 2, 0, negative 5.
So you'd always put a plus 2 in there.
Well, plus 0, minus 0, it doesn't matter.
Okay.
But technically, you
would
leave it
add.
positive, yeah. And then you can go through and do the long division. I'm not going to finish it.
Okay.
Because, I mean, it's not hard. It's not hard. You might want to finish it for homework, though.
So
You get stuck.
once we long divide and get our remainder, that's the answer that you're looking
Then you write your quotient
for.
plus your remainder over your divisor.
And we're good.
And you're good.
Just long division. This
Yeah.
really is long division.
Yeah, that's it. It's really simple.
All right, but you said the curveball's coming.
Nope, no curve. Well, a simplification.
So what are we wanna call that? Place
Long.
value substitution or?
You have to account for all the powers. I like shortened versions of things. You have to account for all the powers. You have to think of it as a positional place value system.
So are you an example or was that our example?
That's your example. I'm not going to finish it though. Well, maybe I should.
Yeah, maybe you should.
Oh,
just
alright, I
okay.
should.
Oh,
I'll
come
do
on,
it.
just wait.
What? You'll live, you'll live. What times x to the what times x gives you x to the fourth?
X to the third.
So you get x to the third minus, oh, I'm sorry, x to the fourth here. X cubed times x is x to the fourth minus x to the third. And then you take this whole thing and you
Change the sign.
change the signs or subtract it. Okay. So that'll give me x cubed. Bring down the next term, which is minus 2x squared. Stop fussing, Paul.
I'm not fussing, I say nothing.
What times x gives you x cubed?
X squared.
Positive x squared. You need that the sign to give you connections between your polynomial. X squared times x is x cubed. X squared times negative 1 is negative x squared. But you have to remember to go through and change all the signs so that's really positive x squared. So negative 2x squared plus x squared is negative x squared. And then bring down, even though it's nothing, you're still bringing down 0x. Okay. What times x gives you negative x squared?
Negative X.
Negative x. Negative x times x is negative x squared. Negative x times negative 1 is positive x. But you have to take this whole thing and change all its signs. So that plus x is really minus x. So this is negative x, and then bring down your negative 5. And then what times x gives you negative x? Negative 1. And if you multiply it down, you get negative x and positive 1. And subtract the whole thing, and we get a remainder of... Nope. Change the signs. That's really a negative 1. Negative 1 plus negative 5 is negative 6. So my final answer is x cubed plus x squared minus x minus 1 minus 6 over x
X minus.
minus 1. Isn't that awesome?
I learned this.
Okay, the problem with this. Way too much writing.
Way too much who?
Writing. Look, I mean, I wrote x to the fourth twice, x to the third twice, x squared twice, x
That's
twice.
all right.
But I wrote it too many times. I also, I really didn't use anything in the first positions here all the way through. So, I mean, literally, if you look at this, I really didn't use this other than to get the number up top. I really didn't use this one because it goes away, this goes away, this goes away. So those really become, well, wasteful writing. Way too much writing. The other thing that gets in the way is these powers, the x's. I mean, we're really not looking at the x's, we're really looking at their coefficients. So what I'm going to do is what's called synthetic division. Technically, you're not supposed to see it in Math 80, but some teachers show it.
Yeah.
You're not supposed to see it. You're not supposed to see it.
Are you gonna test this on both of them?
Heck yeah.
Yes.
More on the synthetic than on the long. So here's what we're going to do. We're going to take the x to the fourth, x squared, and minus 5, and write it out in a positional place value system. In other words, we need those zeros. And I'm going to ignore the x's completely. So the coefficients are 1, 0, negative 2, 0, and negative 5. And if you look at this, the negative 5 is your 1s, the 0 is x, the negative 2 is in the x squares position, 0 is in the x cubes position, and 1 is in the x to the fourth, just like a regular old number, except now we're talking about x's being the base, which is kind of cool. We're going to divide. To divide in synthetic, you just put a little box over here to the left. Woohoo! The number we're going to put in there is kind of important. It's based on this number, or this polynomial x minus 1. But I want to take care of something. I'm sick of putting little minuses that weren't there to begin with. So instead of working, we're getting rid of x's, so we're left with negative 1. Instead of working with negative 1, change the sign automatically, and that fixes all the minus signs later on. So I'm going to synthetically divide by 1. You draw a line.
I forgot what you did after that.
Well, the thing here is, the coefficient here, whatever it is, ends up here. If this was 5x to the fourth, you would write up here 5x cubed. Oh, by the way, this only works if the lead coefficient is 1. All right, so part of my quotient, the first number is going to be the first number. Automatically, if that was a 2, the first number would be a 2. So when I get down here in the bottom, this is actually my quotient. Q of x is down there. Okay? Now, once I put this 1 up here, it's 1 times 1. And you write your answer over here, and then you add. So, 1 times 1 is 1. 1 plus 0 is 1. That's this 1 right here, sitting in front of that x cubed. 1 times 1, 1. 1 minus 2, that's this 1 right here. Negative 1. 1 times negative 1, negative 1 plus 0. Negative 1 plus 0 is right here, and the negative 1 is right there. 1 times negative 1, negative 1 minus 5, which is, of course, the remainder. And if you look at it, this is negative 5 minus 1. So the synthetic division does everything that one does without touching x's whatsoever.
Why did you automatically draw that box around the negative 6?
It's just this, that's the
The
remainder.
last one's
But
automatic.
how do you know that if you don't do the long division first?
It's the last one.
The last one is always the remainder.
Even when I was over here, I don't continue on and say, oh, what times x is going to give me negative 6? I could, but...
Sometimes your remainder will be 6, and you still always draw the box.
All right.
Now, here's the other cool part. The top one has 1, 2, 3, 4, 5 numbers, but the degree was automatically 4. The bottom one has 1, 2, 3, 4 numbers. You do not consider the box one. That's why I put a box around it. If it's 4 numbers, the degree is? No, it is not. It's 1 less.
Why?
5 numbers, degree is 4.
Okay.
4 numbers, the degree is 2 numbers, the degree is boringly 1, which is a silly polynomial. So this must be x cubed plus x, x squared minus x minus 1 minus the 6 over your divisor of x minus 1. So you should be able to pull your answer right out of synthetic division. Do we have time for one more? Not really. We'll finish that up. Tuesday, today's Thursday. But synthetic division is cool. It's fast, and it has a lot of neat little properties.
Because if you learn how to long divide,
Last class we talked about long division, synthetic division really quickly. We're going to do more synthetic division today. I have to throw a bunch of theorems at you today, so you're going to get sick of them. But they do.
Are we going to use those theorems?
Oh my gosh, yes. That's the sad thing. I don't want you to verbatim them. I want you to understand how they are used to solve some of these equations that we're going to come up with. So to finish 3.3, we have to talk about...
3.3, your video only stops at 3.2.
Yeah, I know, because I'm cutting it off and I left the other half off. You watched it.
Yeah. Oh,
Were you here last night?
No.
You were. All right, you had to go someplace.
we had fun.
You went, yeah. So I'm not going to feel bad about it.
Wow.
It'll be up, all of it will be up tomorrow. All of it will be up tomorrow. So, should we review really quickly?
Yeah.
Yeah, why not? I don't remember if I did this one. Oh, let's do this one. I don't even know where this came from. Did we do this one?
What is it?
3x cubed plus 2x squared minus 192x minus 137?
No.
No?
No, the one example you gave for polynomial division was,
So
the divisor was 2x minus 3.
plus 2x squared minus 192x minus 137. And I want to divide this by x plus 8. Okay. And I'm going to show like 3 different things with this one, so be patient with me. There's little subtle details in here that we have to know. So we're going to first do it by long division. So x plus 8 is the divisor. The 3x cubed plus 2x squared minus 192x minus 137 is the dividend. And we're trying to find the quotient and remainder. Okay. Now this is an easy one because it's just x plus 8 instead of something like 2x minus 3 where things get a little messier. So this should be pretty easy. What times x gives you 3x cubed?
3x squared.
So you put 3x squared up here. I'm going to go really fast. Distribute it out. Don't forget to distribute to both of them. So you're going to get 3x cubed and then a positive 24x squared. What do I do with that? Subtract it, change the signs, one of the two, both result in the same thing. So that should become, the first two of course cancel out. This becomes negative 22x squared, because that becomes a minus 24x squared. Alright, and then bring down the next term, which is negative 192x. What times x gives you negative 22x squared? Negative 22x. Distribute it out, you get your negative 22x squared, and you get, I don't know what that is, 176?
176 negative.
Negative 176x. And subtract this away, or change all their signs. So that becomes a positive 176. And 192 minus 176?
Negative 16.
Negative 16x. Oops, 16x. And then bring down the negative 137. Alright, what times x gives you negative 16x?
Negative 16.
Negative 16. That's why it's nice when it's a lead coefficient of 1 over here. Alright, so this gives us negative 16x, and it's going to give me a negative 128. Again, we're going to take this whole thing and change all the signs. That's a positive 128, which leaves me a grand total of
Negative 9.
negative 9. So there's my remainder. My quotient is that 3x squared minus 22x minus 16. And my final answer, if I want to write it properly, would be 3x squared minus 22x minus 16. Because this is negative, I'm going to write it as a minus a fraction. What's the fraction? 9 over x plus 8. And that becomes the solution of that ugly polynomial divided by x plus 8. Yay. And like last class, we were talking about how so many things are repetitive there that we can kind of shrink it down. So let's do the shrink down method now. The shrink down method treats this value here, this dividend, as a place value system. In other words, you get rid of the x squares, the x cubes, the x's, and you just write the coefficients. Be really careful. If there's a power missing, you have to put a placeholder to 0, just like in our numbers like 1092. So we're going to write it as 3, 2, negative 192, and negative 137. So it's understood that each one of these values represents a place. The 137 is in the 1's place, the 192's is in the x's place, the 2 is in the x squares place, and the 3 is in the x cubes place, just like the regular place value system. And we're going to synthetically divide by this x plus 8. And remember when we were talking about this, I want to take care of the subtraction right away. I don't want to be changing signs halfway through the problem. So instead of dealing, first off, the x goes away. Second off, I don't want to use a positive 8. I'm going to use
-8.
a negative 8 because that'll change all the signs automatically. Okay. Now, part of the quotient, the first number, is always going to be that first number of the dividend. So, because this lead coefficient is 1, we can just take this 3 and drop it. It becomes part of my solution, part of my quotient. Next step is multiply. Negative 8 times positive 3.
-16.
Negative 8 times positive 3.
Oh, sorry.
Negative 24. And if you look at it, the negative 24 is right here. Remember, you have to change the signs in the long division part. Subtract those, you get negative 22, which is right here. So all the numbers are going to be accounted for with this shortened version of long division. This is synthetic division. Negative 8 times 22, if I remember right, was 176. And then when we subtract those, we got negative 16, which is, right here. Negative 8 times negative 16 is, where is it? 128. And then our final remainder was negative 9. And if you look at it, all the numbers that were on the left here are still accounted for, the important ones at least. We have a 3, a negative 22, and negative 16 is our quotient. We have our negative 9 as a remainder. So when you take this number off, this is the quotient. And you take it off in place values. This is the 1's. This is the x's. This is the x squares. So if you have 3 numbers, you're dealing with a quadratic. If you have 4 numbers, you're dealing with a cubic. What if you have 7 numbers? What's the degree of the polynomial?
7.
If you have 3 numbers, you have a square. If you have 4 numbers, you have a cube. If you have 7 numbers, it's a 6. It's always one less than the number of place values you have, is the degree of the polynomial. All right, so the answers are identical. That's the beauty of synthetic division. Here's the, go ahead, Paul.
No, go ahead, you might answer it.
No, I'm gonna go on.
You said from the very beginning you dropped that first coefficient to 3.
Always.
What if it's not your lead
Oh.
coefficient and divisor isn't?
If your lead coefficient is not 1, you can't do, well, you can do synthetic division, but it gets weird. Like, for instance,
Oh,
no,
okay, so
you
the
can do
synthetic
it.
only works with a load, well, not only, but generally works with a,
Let me give you a quick example. If this is your setup,
okay?
right? To make this work with synthetic division, you have to divide everybody by 3.
Just to get it to the 1.
Just to get that one by, and I mean everything. So this would become x squared minus 2/3 x plus 1/3 divided by x minus 2/3.
Okay,
So when you set up your synthetic division, it would be 1 negative 2/3,
yeah, I got you.
1/3, and then you synthetically divide by 2. You see where it's getting messy?
Yeah, man, no, I'd just stick with the long
I would do the
division,
long
yeah.
division on that one myself.
Gotcha, now I see
Yeah.
it, okay.
But yeah, for synthetic division, that lead coefficient has to be 1
Okay.
because we do want this number to drop. And if
Alright.
it's not 1, it's not going to drop. All right, the other thing I want to show you on this, which is really cool, and it's extremely important. If I set up this function, and you'll notice it's exactly the same as my dividend over there. Ooh, not minus 137. And this is my function. And I take my function and I evaluate it at negative 8. Thank God you all have calculators, right? Because this would be horrid to do by hand. So this would be 3 times negative 8 all cubed plus 2 times negative 8 all squared minus 192 times negative 8 minus 137. If you did not have your calculator, would you do this? No. Now, how long have calculators been
If I had
around?
to.
About 30 years?
If I had to, I would.
Yeah, it would take you some time though, wouldn't it?
Well, a little bit.
Yeah.
Yeah, because you'd have to cube out that -8, which is, just nasty to begin with. Then you have to take that and multiply by 3. Then you have to square -8, and you have to multiply that by 2. Then you have to take -8 and multiply it by 192. And then finally subtract 137. It's a lot of calculations going on there. But after you're all said and done, what do you get?
-1,353.
Nope. I already know what the answer is.
Well, tell me, what is it?
-9.
Oh, you said negative.
But that's the remainder.
Exactly.
I put.
So, which calculation would you rather do? Cubing, multiplying, adding, and subtracting, or just simple multiply, add, multiply, add, multiply, add, multiply, add, and get the same answer? This does turn out to be -9.
Yep, you're
But
right.
that's the remainder of the answer.
Yeah. That's the beauty of it. So to calculate a polynomial, I don't have to actually plug it in and figure it out. I can set up the synthetic division, divide by what I'm trying to evaluate, and my remainder is going to be my answer. It's actually a very cool thing. So this is called the remainder theorem.
So you still have to do the other stuff, but you just,
Well, it gives you a choice. You can evaluate a function normally, but sometimes it becomes
Tedious, yeah.
it becomes a lot of calculations and bogged down with the powers, especially when that power keeps getting bigger. You raise that to the 9th power, and all of a sudden, all bets are off by doing it by hand. So synthetic division used to be used as a calculation tool for polynomials. You would just do the adding, multiplying, then you get an answer, and it's
Late
not
to
that
show
hard.
us that.
What's that?
Listen, a little late to show us that. Can you show us that, like,
No. This is higher level math, baby. So, given p of x is divided by something like x minus c, and the remainder is r, then p evaluated at this value c is also equal to r. Beautiful theorem. Very, very powerful.
All right, now that leads me to a question, of course.
What are you talking
What do you mean, what am I talking about? Exactly what happened up here. I can evaluate the function normally, or I can do the synthetic division. The remainders will be exactly the same.
about? So are you just looking for the remainders?
Yeah, why am I important? Why is the remainder important? We'll talk about that in a second.
Yeah.
It's very important. Yeah, let me give you a hint. 7 goes into
Wait,
30. How many times? 4. 4 times 7 is? 28. You subtract it and you get 2. So what does this mean? Well, it means that 30 divided by 7 is equal to 4 plus 2 7s, right?
yes.
yes.
Okay. If there was no remainder, like 7 goes into 35, how many times does 7 go into 35? 5. 5 times 7 is 35. It goes in, what do we call it? Evenly. It goes in evenly. So if we set this up, my answer would be, well, 35 divided by 7 is equal to 5, and no remainder. So what's the difference between having a remainder and not having a remainder?
I guess having a remainder, you'll have a fraction.
Well, having a remainder, you'll have this extra fraction. Without it, you don't. Also, if you look at the setup, I can take the 7 and move it over here and have 5 times 7 is equal to 35. So what did I do to 35 if I set it up that way? You take 35 and breaking it apart
You're
into
dividing
it's begins with an F.
Fraction?
Factors. That's the important part. So I'm taking numbers and I'm being able to factor them if they have a remainder of 0, which is the next theorem.
Oh,
Hold what?
oh, no, I got something that looks like one of them theorem things over here in my notes from the other day.
Uh-huh.
And I
Intermediate value theorem?
It's in my handwriting, but I don't remember writing.
One up, one down, it has to cross in somewhere. in
No,
between.
it's px over 2x minus 3. It had to do with one of the polynomials that gave us an example in the long division. But px over 2x minus 3 is equal to,
Q of x plus r of x.
that's right.
Yep,
What is that?
that's this. P of x divided by 2x minus 3 is equal to q of x plus r of x. That's all it means, is you have a quotient and a remainder. And the cool thing is, what happens when that r of x is equal to 0? So that becomes the factor theorem. My markers are all dying.
Well, wait a minute, what is it, the remainder theorem or the factor theorem?
No, the remainder theorem just says that the polynomial evaluated at a point is the same thing as doing synthetic division. That's all that one says.
So, the two steps that you just showed us, that's synthetic division.
Synthetic division.
Synthetic.
This weird stuff here. Synthetic division.
And that's what the remainder theorem states.
It just says there's a relationship between synthetic division and evaluation.
Okay.
That's all it says. Factor theorem. This is much more interesting. P of x divided by x minus c is equal to q of x plus r of x. We've already talked about
Oh, yeah,
this.
because we've got enough to remember.
Yeah. Well, a lot of this isn't remembering, it's using. It's how to use it.
Well, you gotta remember it to know to use it.
Yeah, but we're going to practice that enough. If we let r of x equals 0, then this is what we get. We get p of x divided by some x minus c is equal to some q of x. What's nice about this equation, since there's no remainder added on there, is we can multiply both sides by x minus c. And if you multiply both sides by x minus c, remember p of x is a polynomial. X minus c is a linear factor, if you want to think of it that way. And it's going to be multiplied by this q of x. So if the remainder is equal to 0, we've actually taken this any degree polynomial over here, nth degree. We have actually factored it into x minus c times this other polynomial q of x. What is the degree of q of x? No. If this one starts off at the 5th degree, and I take one factor away from it, this one would be the 4th degree. If this one starts at the nth degree, this one would be
And you say M.
Okay, hold on. Ready? If this one starts off at the 5th degree, this one ends up at the 4th degree. If this one starts off at the 10th degree, this one would end up at the...
9.
If this one starts at n, this one will end up at...
M.
Okay, you're not seeing it. What's the relationship between 10 and 9, 4 and 3, N? I don't want another alphabet. I have n over here. What did you do to 10 to get to 9?
What you want, a number?
No. Think. If you start with 10 over here and you end up with 9 over here, what did you do?
You subtract.
-1.
Subtracted 1. So if you start with n over here, you end up with...
M is what I did.
Negative n.
N-1.
Thank you. n minus 1
Oh, yeah, because that was
degree.
That is hard.
You guys are brain dead.
Come on.
10 to 9, you subtract 1. N to m. I mean, where's that coming from?
We don't do English mathematics.
You need to.
Yeah, I mean,
So it's n minus 1.
Yeah. So whatever this one starts off with, this one's going to be 1 less.
All right.
Which is really important because then we can take the polynomial and reduce its degree. And every time you reduce its degree, it gets closer and closer to the one we can handle. Which one can we handle? What degree can we handle easily?
The first.
First is the simplest. What's the one above that?
Square.
Squared, because we have the quadratic formula. So we can always solve degree 2. So we're going to take this big polynomial and we're going to shrink it down until it gets down to a degree 2. That's our goal. So goal is to have n minus 1 equal 2. Quadratic. That's our goal. We're trying to get this thing down to a quadratic. So that's the factor theorem. If you have a remainder of 0, you're reducing the degree of a polynomial and creating a linear factor. So, how many of these linear factors exist? If this is an nth degree, how many of these x minus c's would you expect? If we factored it all the way out. Alright, if you have a quadratic, how many factors do you normally get? Quadratic? How many answers do you get? 2. So you would expect 2 factors. You know, x squared minus 9 factors into x plus 3 and x minus 3. It only has 2. If you have a cubic, how many would you expect? 3, 4, 4, and so forth and so on. So if you have n degrees here, we would expect n of these things.
N of them?
N, Nancy of them.
Can we use numbers?
Yes, we can use numbers. Here we go.
It won't wait, it just,
Just wait, Paul. Just wait.
I've come
I
to
need
the
you to think
conclusion
positive,
that
Paul.
your ways of explaining us how something came about confuses us. If you just show us.
I need to show you that first
No,
because
normally it
otherwise this
doesn't
will make no
confuse me.
sense.
but
What? If r is equal to 0, I can rewrite this as that. I mean, that's just logical. I can multiply
Right.
both sides by x minus c. If you write this, you have a polynomial here is equal to a polynomial times a polynomial, which means you've taken a polynomial and actually factored it.
right, I follow that.
That's all that I need over there.
Oh,
Aye.
why did you say all that?
Because I need you to understand what's happening. If you start with an nth degree here, you're going to lose a degree because I have a linear factor.
Okay,
Okay. Why do you want to argue with me?
I'm not arguing.
You enjoy it.
I know.
Yeah.
I like torture.
No, I think it was the nth degree that was kicking.
Nth just means any number you wish to choose. 5, 10, 15, 20. It just allows
Right, no, I got to remember that, but it's just, I
you
don't
used it before.
speak.
So, if x minus 8 is a factor of this polynomial f of x, what can I do to factor it completely? Or find all zeros roots, depending on what's going to happen to this. We'll do it one way or the other. All right, what's a 0? What's a 0?
Do me one courtesy before you start going into that. What is, show me before you start going down your little board there, the relation between that equation you
This
just
is
wrote.
p of x. This is the big ugly polynomial, p of x.
Okay.
This is
And
one of
that's
its factors. This is x minus c.
Okay,
We're trying to find,
all right, I'm with you.
what are we trying to find?
Q of x?
Q of x. It's the only thing left.
Yeah,
It's
exactly.
the only thing left.
I'm, like I said, I'm with you.
All right,
All right.
so what's a 0 of a function?
An x,
An x what?
an x coordinate.
A what?
Is it intercept?
It's an x-intercept.
That's what I'm- that's what-
Zeros and roots are very similar. It's just that zeros are real numbers and roots are real numbers or
Imagine.
complex imaginary. So when I say zeros, roots, zeros is just the real part of things. Roots allows for it to be imaginary or complex. Okay, so let's start off. What can I do knowing the fact that x minus 8 is actually a factor of f of x? Well, if it's a factor, then the remainder must be equal to? If it's a factor, then the remainder has to equal 0. And if I get it down to 0, I can find this q of x, which has a 1 degree less than a 3. What's 1 degree less than a 3? 2, which would be a quadratic, and I can do anything I want with that one. So what I should do is set up some synthetic division. 1, -6, -40, 192. And I'm going to synthetically divide by 8. Positive 8 or negative 8?
Positive.
Positive 8. You're going to switch the sign when it's written as a factor. If it said x equals -8, then you would just leave it alone. Draw a line, drop the first number. Okay. 8 times 1? 8 minus 6? 8 times 2? Quiet. 16. I don't know why I wrote 12. -40 minus, or I'm sorry, -40 plus 16? -24. 8 times -24.
-192.
Really?
Yeah.
I would hope so, because otherwise it wouldn't be a factor, because then the remainder wouldn't be 0. We knew that the remainder was going to be 0.
We did.
Well, yeah, because x minus 8 is a factor.
It is a factor.
To be a factor, you have to have a remainder that's
All right.
equal to
All right,
0.
I'm getting it. I'm getting it.
So now we have these 3 numbers. What do these 3 numbers represent?
X squared.
X squared,
2x.
plus
minus-
2x
It's minus 2x.
plus 2x. It's positive.
Move your body, I can't see. Minus 24.
You're exactly right.
Minus 24.
Minus 24.
Now, I have two choices. If it factors, great. If it doesn't, quadratic formula, completing the square, something like that. Are there factors of 24 that subtract up to 2? 6 and 4, so it does factor. So we're going to factor this into
Oh, man.
x6, x4. What kind of 6, what kind of 4?
Positive 6.
Positive 6, negative 4. So if we want to factor f of x, it would be x plus 6 times x minus 4 times that original x minus 8. And this is the exact same thing as f of x.
See,
Ah.
why you just couldn't do that?
Yeah, but if I did that, you wouldn't understand why I was
I
doing
don't need to
that.
understand why.
Yes, you do. This is a math class. I try to
So
teach
you're
you why.
literally, so basically there is a direct relation between the remainder theorem and the factor theorem.
Yes, because the remainder theorem says, yeah, I get this r at the end. The
But
factor theorem
this
says,
is
well,
really-
what if r is equal to 0? It goes away. And then you're left with that situation.
All right, so in order to run through the factor theorem, you have to apply the remainder theorem.
Yes. And we're going to be using the
All
remainder
right, I
theorem
feel
more
so
than the factor theorem.
I'm right there. Well, I mean,
Now, if I was looking for zeros and roots, what would be my solutions? X equals
oh,
Negative 6.
negative 6, positive 4,
and positive.
positive 8. Ta-da.
Cool.
All right.
All right, don't erase nothing.
I'm going to erase over here. It's like pulling teeth.
I don't see how people are taking
I should become a dentist.
No, it's not. Because that's painful.
Exactly. I like that.
Yeah, it's more sensitive.
Did that.
You are so.
They ask if you're okay.
Alright.
Nope.
Problem. Well, several problems.
All right, so wait a minute.
So we got problems in there?
So we're going to apply
Well, we have a problem because
the remainder theorem.
to factor this one, I had to tell you what the original factor was. The problem with that is I'm not going to always give you the original factor. This becomes actually a simple problem. So what happens if I don't give you the original factor?
You gotta find it somehow.
How many possible answers can you shove into the synthetic division? Infinite, which is just way too many to even try. So I have to come up with a way of reducing the number of possibilities. Oh, just a little small theorem that comes in handy. It's called the N Zeros Theorem. Given P of X is a degree, I'm not sure if I gave this to you already.
No, sir.
No, degree N polynomial. Then P of X equals 0 has at most, talk about that in a second, N zeros.
I think that one is dying too.
It is. I write way too
Oh, man, see.
Now, this one's easy. If P of X is a degree n could be any number that you choose. Then if I have basically what I'm looking for here is x-intercepts, P of X is equal to 0. If I have this equation, it has at most n solutions, n zeros. All right, what does it mean to be at most? Like for instance, if my degree was 4, will I always have 4 solutions?
No.
No, I could have 4 solutions or 3 or 2 or 1 or none.
Okay.
Okay.
So at most, because this is,
At most means that's the maximum you can
Yeah.
have.
no, because this is dealing with our statistic class too. At most, is that greater than or
Less than.
Less than.
Less than.
At most is.
That's what I'm saying, it's the maximum. You can go under it, you just
Gotcha.
can't go above it. So, I mean, we could draw a degree 4 polynomial. You know, you could do, it's basically a W shape. So this would be one that has 4 solutions. This one would be one that has 3 solutions. It would only hit the x-axis here, here, and here. This one would only have 2 solutions. It would have one here and here. And of course, no solutions is you just lift it right off the x-axis. What about a third degree polynomial or a fifth degree polynomial? Well, let's say fifth. You could have 5 solutions, or you could have 4, you could have 3, you could have 2, you could have 1. Can you have 0?
Yeah.
Odd degree polynomial. Why not? There's got to be a reason why you have to have a solution with an odd degree polynomial. Why does it have to have a solution? What does an odd degree polynomial look like, and behavior-wise?
Oh, one goes up, one goes down?
One goes up, one goes down. Now, if one goes up and one goes down, can you ever not have a solution? Why?
Because it's always going to go through.
What theorem?
Oh, the line, is it the line? Vertical line?
No.
No, it's verbal on test.
It's a theorem. I said it was a theorem.
Is it a theorem you gave us?
Yes.
Yeah, he
Yeah,
just
you
gave
just
us
gave it.
One down, one up.
Cause I just wrote it down yesterday.
One down, one up. One down, one up.
that blasted.
One down, one
An
up.
intermediate value.
Intermediate value theorem is one of, as long as one point is above and another point is below,
Something has
you're
to be-
guaranteed that something happens in between them because they're nice continuous functions. All right, then there is this N roots theorem, which is very close to the N Zeros theorem. And it states, given p of x is nth degree, then p of x equals 0 has exactly n roots.
Okay.
Now, why are they different?
Yes, please.
Okay. This one, we're talking about zeros. Zeros have to be real. Have to be real. So that's why you get these different setups. Now, this one says it's a root. What's the difference between a root?
Oh, wait a minute. Never mind.
Roots can be complex.
That would.
So if you set p of x equal to 0 and you allow for complex solutions, you're going to get all of them. So if I say find the solutions of a fifth degree polynomial, guess how many I'm looking for?
All 5.
All 5. I want all 5. If I ask you to factor it, you might not find all 5 to factor it. But if I ask you to solve it, I'm looking for every single one of them. Real and complex.
That sounds like something you ask us.
Alright. So we have remainder theorem, which is really nice. We have factor theorem, which allows us to break things down. We have these N zeros and roots theorems that tells us exactly how many we're looking for, or approximately, at least a maximum number. So that leaves us into 3, 4. Rational root theorem. This one's not horrible. Not bad, but as we take all these theorems and we start putting them all together, you just have to remember things like the intermediate value theorem, one down, one up, there has to be a solution, factor theorem and remainder theorem, and a few other little things besides. This one's probably the most important one, the rational root theorem. The problem with the factor theorem is there's an infinite number of possible ways of finding the factor. What the rational root theorem does is it reduces it down to a finite set. Not one, it gives you a finite set to at least look at. They're not all going to work. So, given we have some polynomial that looks like this, you know that general polynomial I gave you at the beginning of the polynomial section, in the polynomial function section, a sub n, x to the n, a sub n minus 1, x to the n minus 1, a sub n minus 2, x to the n minus 2, blah, 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 blah.
Sure.
It allows for all degrees polynomials. The rational root theorem only cares about the first number and the last number. That's the beauty of it. It only cares about the first number, the first coefficient, and the last constant. And if p of x has rational roots, what's a rational number? What's a rational number?
No, one. No.
One's a rational number, sure. What's a rational number? What's the definition of it?
Fraction.
It's a fraction, basically. It's basically a integer divided by an integer where the bottom can't be equal to 0. So if p of x has these rational fractional roots, then it or they will take the form a factor of a sub 0 divided by a factor of a sub n. A single factor of the last number divided by a single factor of the first number. Kind of doesn't make sense, does it? So let me show you what I mean. If I give you a function f of x, and I say it's equal to 3x to the fourth minus 2x squared plus 7x minus, not 12, minus 12. It's a fourth degree polynomial. Is there anything missing?
Yeah, the third
The
degree.
cube. You have to kind of get used to it. If there's something missing, you have to recognize it. So if we were going to synthetically divide, it would have to be 3, 0, negative 2, so forth and so on. What is a sub n in this case? What's a sub n in f of x?
3x. Oh,
3.
just the 3.
Just the coefficient, 3. So a sub n is right here, and it's equal to 3. Where's a sub 0?
12.
It's going to be 12. And I'm going to allow you to just to say 12, not negative 12. We'll take care of sign at the very end of this problem, not at the very beginning. So possible rational roots, they're not guaranteed. This is, if it does have rational roots, then they will come out of my list that I'm going to create. I'm going to be looking at factors of 12 divided by factors of 3. Okay. So what are factors of 12? In other words, what divides evenly into 12? First number?
3.
2,
1. 1's always going to be the first number. So 1, 2, 3, 4,
6,
6,
And
and 12. Factors of 3?
1 and 3.
1 and 3. So it's not a huge list. Some of these get a little bit crazy, but this one's not too bad. Your next step is, it's just one of the factors on the top divided by one of the factors in the bottom. So what you do is you basically take all the top and divide it by 1, and then turn around and take all the top and divide it by 3. So this will become a set of numbers, and I'm going to allow it to be plus or minus. That takes care of the possibility that it might be positive or negative. So it's 1 divided by 1, 2 divided, you just basically get the top numbers. 1, 2, 3, 4, 6, and 12. And then you divide everything by 3. If it reduces, we don't need to write it down, and you'll see why in a second. So 1 divided by 3, 2 divided by 3, 3 divided by 3. He's already in the list. So if it reduces, it's usually already, well, actually I'll guarantee, it's guaranteed to be already in the list. 4 divided by 3, 6 divided by 3, it's already in the list. 12 divided by 3, it's already in the list. So these are the possible rational roots of f of x. Now because I kind of randomly generated f of x, more than likely none of these are going to work. Because I didn't set it up so that it does work. So let me show you how this works with something that does work. Oh, by the way, one of my test questions is that. And you stop. You don't go looking for the roots. If I ask you for the possible rational roots, all I'm looking for is the list. That's all I'm looking for.
You know, it's gonna be star and text question.
Ted, well, you're going to steal the test
I
questions.
did. Curiosity is
No.
important.
You say that, but no.
It's too easy to be a test.
Oops. No, it's not.
That's the,
That'll be extra credit.
those are his favorite ones. Just to trip you up.
Here's a nice little equation. And I want to find all the solutions. How many am I looking for?
1, 2, 1, Oh, infinity.
Now, how many solutions will this equation have?
4, 3,
Why are we guessing?
because it's cubed.
Oh, because it's cubed, we're looking for exactly 3 answers. You have to get used to that. It's the degree is how many you're looking for. All right, so I want to either A, factor this, or eventually get it down to a square so I can use the quadratic formula. So what should I start with? Well, what you should start with is a sub 0 divided by a sub n. What's a sub 0 in this case?
1.
No, 36. It's the last number.
The last
A sub n is the first number, which is 1. So if we factor 36, we're going to get 1, 2, 3, 4, 6, 9.
36.
No.
It's
12,
18.
18,
Now 36.
and then 36. Okay. And of course, this is all divided by 1. Yes, you have to list them all out. Okay, so all I'm going to have to test is, well, it's divided by 1, so I can just make this my set.
But you gotta do plus or minus.
You have to do plus or minus. Just do plus or minus. They could be positive or they could be negative. So now I have this possible rational roots. What should I do next?
That's it.
You didn't tell us.
Well, I want to solve this. So what do I need to do? Well, I need to take these numbers.
Are you gonna try to plug them all in?
I'm going to try to plug them all in and see which one gives me a remainder of
0.
0. All right. So let's set this up for synthetic division. I definitely don't want to do it long division style. So this is 1, 10, 15, negative 36. Should I get you used to it? Yeah, let's get used to it. This is called quick synthetic division. I'm moving the box down one.
Moving what box down?
The divisor box. I'm moving it from next to the 1 down 1. What I'm going to do is I'm going to get rid of that middle line. I'm going to get rid of that middle line in synthetic division because generally that's just the adding part. I can pretty much do that in my head. So I'm just going to get rid of the middle line and condense it. What this allows me to do is to do synthetic division over and over again until I get to my answer. Instead of setting it up, seeing if it works, setting it up, seeing if it works. I don't want to keep setting it up. So I'm going to set it up as 1, 10, 15, negative 36 is my dividend. And then over here I'm going to put my divisors, one right after the other until I get a
Hold on,
0.
let me get a
What about the,
clean sheet over
nope, never mind.
Well, I'm going to pick a number. Pick a
Oh,
number.
never mind, I'm sorry.
Pick a number out of that list.
1.
One's usually the best thing to start with. So you put a 1 here. The first one is going to drop down into your solution. So in this case, it just drops right next to the 1. And then you go 1 times 1 is
1.
1 plus 10.
1 plus 10 is
Yeah, because even with, it would just be 1 plus 10. So this would be 11. 1 times 11. 11 plus 15.
26.
26. And 1 times 26. Minus 36.
Negative 10.
Negative 10. And this will be my remainder over here. So there's my divisor. There's my remainder. My
It's not
quotient is this 1, 11, 26. But it didn't work because I ended up at negative 10. All right, so what number do you want to try next?
2.
2. Why not? It's in the list. Best to go in order. You start jumping around and picking 1, 5, 6. You're not going to see some things that might happen. So 2. Drop the 1. Now, be careful. This is where people make mistakes. You have to go to the top line to do your calculations. This middle line here is gone. It's really not there
Why don't you
anymore.
just block it out?
You can if you want. 2 times 1 is 2 plus 10 is 12. 2 times 12, 24 plus 15,
24 plus 15 is 39.
39. 2 times 39 is a big ugly positive number minus 36.
78 minus 36 is 42.
And I could care less. It's positive.
Because at that point, you know it, oh, yeah.
It's not going to be 0. That's the important thing. But I do care that it's positive. Why do I care it's positive?
Because 0 cannot be positive or negative.
No. Look what just happened. Negative 10, positive number. What has to be true?
They gotta be positive.
No. This is a y equals negative 10. This is a y equals some positive number. If you plot them, one's going to be low and the other one's going to be high, which kicks in what theorem? Intermediate value theorem. That means there's a solution somewhere between 1 and 2. But the problem here is there's no number up here between 1 and
Whoa.
2. Oh, hold on. This list is all the possible rational solutions. But my intermediate value theorem is saying there's a solution here. But it can't be rational, so what does it have to be? Irrational. Now there is no irrational root theorem. You can't go searching for irrational roots, so we'll have to find that one later. I know it's there. One of them is between 1 and 2. Alright, let's keep going on our merry way.
Well,
I can't do anything because there's no root up here between 1 and 2.
oh, so we're trying to find all possible.
Yeah, we'll get them. Alright, what number do you want to try next?
3.
Nope.
You say go in order.
I know, but I gotta give you one more.
18.
Hold on. A new tool, right? New tool to help you to stop where you need to stop. Notice these numbers here? What's true about every single one of them? Well, this one up here went positive, 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 negative. This one's positive, 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 positive. If they're all positive, we're going to call this an upper bound. In other words, x equal 2 is an upper bound. That means you are not going to find a solution anywhere above 2. It's just a tool.
Oh,
It just means 2 is the bound. You can't go any higher than 2. So plugging in 3, 4, 6, 9, 12, 18, and 36, not one of them is going to work because they will always be positive all the way across, which means you'll never get to 0. So when I get x equals 2 as an upper bound because they're all positive, not counting the divisor, I don't go to 3, I go negative. Sure, why not? So negative,
Oh, because we did say plus or minus.
yeah. So negative,
3.
oh, why would you start there?
1.
Start with the easy one, 1. It might work, you never know.
Wait,
What?
Because it has to be in between.
I get it.
Okay. No, it's nothing to do with intermediate value theorem. It just has to do with if they all start turning positive,
You just say it's going to be higher.
anything bigger than that is always going to be positive. I mean, if you want, try 3. 3 times 1 is 3. 3 plus is 13. 3 times 13 is 39. Plus 15, it'd be a big positive number. It'd just be all positive. So drop the 1. Negative 1 times 1.
Negative 1.
Negative 1 plus 10.
9.
I'm worried. Negative 1 times 9. Negative 9 plus 15.
Positive 6.
Negative 1 times 6. Negative 6 plus 36.
30.
Negative 30. No.
What?
Negative 6 plus negative 36.
Negative 42.
Negative 42. It's negative. Alright, so negative 1 didn't work, so we're going to try negative 2. So negative 2, drop the 1. Just remember, this is actually not that bad compared to infinite.
Yeah.
This is much better than infinite. And we keep reducing how many because we have this upper bound. So negative 2 times 1. Negative 2 plus 10. Negative 2 times 8 is negative 16. Negative 16 plus 15 is negative 1. Negative 2 times negative 1 is 2. 2 minus 36 is negative 34. Yes, you should be able to do calculations that quick.
Ooh, math instructors, baby.
No, it's just calculations. This has nothing to do with math. This is arithmetic.
Okay, we know that these little simple numbers aren't going to get it.
No, don't assume anything. Don't just jump ahead because what you'll do is jump.
I miss it.
Oh, yeah, and that's the danger. So if you go in order, we get information. Right now, they're both below the x-axis. Drop 1, negative 3 times 1. Negative 3 plus 10. Negative 3 times 7, negative 21. Negative 21 plus 15. Negative 6. Negative 3 times negative 6. 18 minus 36. Negative 18. Now, there is some information here. Negative 42 is way down. Negative 34 is not so way down.
It's decreasing.
Negative 18 is getting a little bit closer to where we want to be, the x-axis. But I don't know when it's going to. Don't jump.
Negative 6.
Don't jump. I'm telling you right now, don't jump. So, try the next number.
Negative 4.
Negative 4. These polynomials, they go very fast sometimes, so you have to be really careful. Negative 4. Drop the 1. 1 times negative 4 is negative 4. Negative 4 plus 10 is 6. Negative 4 times 6 is negative 24. Negative 24 plus 15 is negative 9. Positive plus negative 36 is?
0.
That's what I'm looking for. That's why I tell you don't jump. Because if you jump, you're
But
gonna.
sometimes
Wait a
if
minute.
you jump and the other
Some-
number is too high,
You might
then
get
you
lucky.
would know that it's
You
there.
might get lucky, but it's very rare. So what does this tell me? Well, I got a remainder of 0. That means I can kick in the factor theorem. So one of my factors is,
Or negative 4.
well, x equals -4 is the solution. What's the factor?
1, 6, and negative 1.
Where does x equal -4 come from? Well, it comes from a linear factor, x plus 4. So the linear factor is x plus 4. The solution is x equals -4. I want you to be able to go back and forth between these two.
Okay, so wait a minute, x plus 4 is the
Linear factor, and x equals -4 is the solution. So 0.
and then
This is 0. Now, why is it important to get these zeros? Well, I took a third degree polynomial and I've reduced it down to quadratic, because there's only 3 numbers here. So if I get it down to 3 numbers, I'm done. I don't need to do any more synthetic division. I just need to take this off to the side and say, well, that's x squared plus 6x minus 9. In this case, I'm thinking I have to set it equal to 0. Why? Well, are there factors of 9 that subtract up to 6?
3.
Subtract?
No.
No, because they have to be -3, or +3, and +3. To get -9, though, you have to have one positive and the other one negative. So, I need to solve this. What's the easiest way to solve this equation? Nope, it doesn't factor. That'd be beautiful. It did, though.
To complete the
Complete the square actually works better on this one because the middle number is even.
Oh, it's
It's even. If it wasn't even, I'd probably do quadratic formula. But because it's even, let's practice completing the square. So this is x squared plus 6x. Kick the 9 to the other side. Half of 6.
3,
Square it
9 plus 9.
and add 9 to both sides. Make sure when you move this 9 over that you change its sign.
So it's going to be x
plus 3.
X plus 3,
3
all squared, is equal to 18. And then we're going to get x plus 3 is equal to plus or minus.
x plus 3 is equal to plus or minus. Who's that again? Interrupt that. Oh, no.
Green bag? All I saw was a picture that I know belongs.
Okay, all right.
They may have it at the front desk.
Okay, thank you so much.
No
I'm
problem.
sorry.
That's all right. Plus or minus?
18.
3
Yeah.
square root of
3 square roots of
2.
2. 3
That's
square roots of
twice
2.
he's done that. That's very rude.
What?
Interrupted our
Oh, no,
class.
that's fine. That's fine.
So I can, if you're in the middle of teaching a good problem, I can go, Mr. Kalari, did I leave a green bag in here?
Now look what
Right.
Interrupted.
Solve it, and you get x is equal to -3 plus or minus 3 square roots of 2. I guarantee you, if you use your calculator and you type in -3, it's going to be in between 1 and 2. Guaranteed that -3 plus 3 square roots of 2 is between 1 and 2, without a doubt. And then there's another answer, -3 minus 3 square roots of 2. So my final answer to this, since I was looking for solutions, is x is equal to the set of values, the first one,
I forgot what we was looking
-4.
-4. The other two, well, -3 minus 3 square roots of 2, and -3 plus 3 square roots of 2.
for. You can't put a lot of these on the test.
Why? They're actually not that bad.
Look, I think.
Speak for
So
You get
that's
used
the
to 'em.
final answer.
No, you don't.
Yes, you do. With practice, you will get used to them. Now, where do people make their mistakes? Let me point them out real quick. They make their mistakes when they do silly things like -2 times -1 is -2. Add that to, they do sign mistakes. Silly little multiplication errors, addition errors, they will kill you. So you have to be very cautious every step of the way. I highly suggest you use your calculator all the way through this calculation. Every single time, because with the calculator, at least if you type it in right, you won't make sign mistakes. Let's try one more.
Okay. Is there a way is there a calculator that exists where you can?
I have a program, but it's a very long and nasty program. It took me forever to write.
Is it real?
It would work on your calculator.
Are you rich from it? Did you publish?
No. Why would I publish a Factor Theorem program?
Because you want to be rich. I'll be a publicist.
No one's gonna buy it.
I'll be a publicist.
Alright, let's solve this one. X cubed minus 11x squared plus 44x minus 60 is equal to 0. How much time do I got?
I don't know.
Oh, I got plenty of time.
Man.
Okay. We're looking for how many answers? I try to keep it small to start with, and then we'll build up on top of it. We're looking for 3 solutions, real and or imaginary. This one happened to have 3 real solutions. This one more than likely
Probably
won't because I set it up that way. So we're going to start this off with a sub 0 divided by a sub n, the last number divided by the first number.
60 over 1.
It's 60 over 1. 60 is horrible because it has tons of factors. 1, 2, 3, 4, 5, 6, 8, 9, 10,
10,
12,
15,
15,
20,
20,
30.
30, and 60. Wait,
God.
did I miss one?
I hope not.
More than likely, though, here's how these usually work, because my numbers aren't really big up here. More than likely, it's not bigger than 5. More than likely, all these other ones are possibilities, but not likely. I would never want you to work all the way up to 60. That would be horrid.
Are you sure about that?
I'm actually quite sure about that. So, let's take off our numbers. We have a 1, we have a negative 11, we have a 44, we have negative 60. Does it make sense? Well, this is a 3rd degree polynomial, and how many numbers did I write down?
4.
4. That makes sense, because it's always 1 less of the numbers I write down. Alright, we're going to do quick synthetic division. What number do you want to try first? 1. Might as well, it's boring. 1 times 1 is 1, 1 minus 11 is negative 10. 1 times negative 10 is negative 10 plus 44 is 34. No, 1 times 34 is, well, 34. 34 minus 60 is?
26.
26. Negative
Negative 26.
26.
I'm sorry, my bad.
Negative 26. Okay, we can stop for a second. Why? Well, before we had this all positives became an upper bound. This one, what's it doing? Well, it's going positive, negative, negative. It's alternating all the way throughout. So if it does a positive, negative bit, what we're going to say is x equals 1 is a lower bound.
Right.
These upper and lower bounds are very nice because it squeezes in your solution so you don't go looking places where you really shouldn't. So what this says is, I don't need to go any smaller than 1. So guess what this does not have? Negative roots. Not a single one. Because if you can't be smaller than 1, you can't be negative. All right. So I'm not going to go smaller, I'm not going to go smaller than 1. So where should I go?
Keep going up.
Keep going up. And that's the only option I have is to go up through this list.
All right.
So, stop it. 2. Jeez. You can do that if you want to, but you'll be there all day. 2 times 1 is 2. 2 minus 11 is negative 9. 2 times negative 9 is negative 18 plus 44.
26.
Positive 26. 2 times 26 is 52. Minus 60 is?
Negative 8.
This one is also what's considered a lower bound. It just says don't go lower than 2. But that doesn't give you any good information. We already knew not to go down. So let's keep going up. Next number?
3.
3. So if I take 3 times 1 is 3. 3 minus 11 is negative 8. Oh, look, they're decreasing by 1. 3 times negative 8 is negative 24. 24 plus 44 is 20. 3 times 20 is? Oh, 60 minus 60 is?
0.
That's a good job right there.
Sometimes they come quick. Sometimes they take a little effort on your part. But this gives me some information. Number 1, I have a solution is x equals 3. Number 2, I have a factor if I want to use the factor theorem. What's the factor?
X plus 3.
X minus 3.
So I take the opposite.
Because what happens with a factor is you set it equal to 0 to get its solution. So they'll always be opposite sign. The other thing that's nice is because our remainder is 0, this is a factor of the original polynomial. So that is a factor of x cubed minus 11x squared plus 44x minus 60. And it is x squared minus 8x plus 20. Are there factors of 20 that add up to 8? Of course not. Why would I do that? So I'm going to set it equal to 0 since I'm, trying to solve for 0 anyways. How would you solve it? We can complete the square, but we already practiced that once. Let's do quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Ooh, 2a. Okay. What's b in this? I'm going to start saying. B is negative 8.
Negative 8.
So it goes here and here. A,
1,
c,
1,
and a again. 1. So the hard part is actually the inside. So we get 8 plus or minus the square root of, 64 minus 80, that would be 14, negative 14?
Let me put
Negative
in
16.
Negative 16.
minus
So that'd be negative 16, all divided by 2. So what's that become?
now. It took you.
How did y'all get negative 16?
64 minus 80.
Always
64.
throw that in calculator.
64
I
minus
put
80.
you're right.
Maybe if you're going to type this into calculator and you type in negative 8, put parentheses around it. What's the square root of negative 16? 4i. So this becomes 8 plus or minus 4i divided by 2, better known as 4 plus or minus 2i. So 4 plus or minus 2i. And there's my other two solutions. Yay. So if I put all my solutions together,
Jesus.
where?
I'm sorry about that.
He's not going to help you.
He will help you.
He will not help you in my class.
Oh, my brain.
He wants you to use your own brain, not
You going
his.
to be to church next Sunday.
So my first solution was x equals 3. My other two solutions, which happen to be complex, 4 plus 2i
4 minus 2a.
and 4 minus 2i. How many answers did I get? 3. What was the degree of my polynomial? 3. I'm done.
All right, homework, let's go.
Huh?
Yeah.
No, I got time. Oh, by the way, there's a theorem here. If you look at this right, what are these two called?
Those are called conjugates.
Where'd you learn English? Conjugates. So, there's a theorem buried in here, and I might as well just write it out for you. It's called the complex
I don't have space.
root theorem. Given p of x has real coefficients. Okay, this gets really weird. Do coefficients have to be real? No, they could be imaginary. We just usually don't work with them. This one is forcing them to be real. They have to be real coefficients. And a plus bi is a root of p of x equal to 0. Then a minus bi is also a root. Basically all it's saying is, if you have one complex solution, then you must also have its conjugate as a solution. Guaranteed without a doubt.
Okay.
Okay? So if I say p of x has roots -2, +3, 4i, and it has real coefficients, what's its fourth root?
Negative.
-4i. Without a doubt, -4i also has to be a root. Ah, that's coming up. So if p of x has these 4 roots, what degree is it?
3.
So p of x is also degree 3. No, 4 roots.
4 roots.
Degree
3, 4.
4. So it gives us information about the degree of the polynomial, which we know basically what a 4th degree would act like. But it also tells me something else. I can find p of x now. How would I find p of x? Well, where'd this -2 come from? It's a root, but where did it come from? Well, I took p of x and I factored it. So what is the factor that's associated with negative 2?
X plus.
X plus 2. What's the factor associated with 3?
X minus 3.
X minus 3. What's the factor associated with 4i? X minus 4i. What's the factor associated with negative 4i?
X plus.
X plus 4i. How do you think I design my questions? There. I start with the answers, and then I come up with the polynomial. And then what do? You take the polynomial and you back it back to the answer. So I already know the answers before you even start working. That's the beauty of my side of the job. Of course, now all you have to do is take this and multiply it all together, and you can have a nice polynomial. Which two would you multiply together first?
The X plus 2 X minus 3.
Yeah, but personally I would do this
Yeah,
one.
they go cancel.
They're conjugates. What happens to the middle terms?
They cancel.
They cancel. This is just x squared plus 16. Makes life easy. And then if you multiply those two together, you get x squared minus x
Out to the odds.
minus 6. And then you multiply that junk together and you get a possible, I said that word again, possible. You get a possible polynomial that is exactly what I want. We'll talk about that next class.
Would that be X squared minus 6?
Out to the odds.
It's negative 4i times positive 4i, which is negative 16i squared. And I squared changes signs, so it becomes.
Yeah.
If it was minus 16, it would be x minus 4x plus 4.
Gotcha.
But because it's plus, we have imaginary roots. All right, homework. 3-3, do all the checkpoints if I have to.